So number 6 is an example of a word problem where there's going to be one variable that equals a total. So our plan is to order t-shirts for our team. There's a one-time setup fee of $70, and then each shirt costs $12. Our order total is 142, and we want to know the number of t-shirts that were purchased. Since we want to know the number of shirts that were purchased, that must be our unknown, so that's going to be our variable, number of shirts. It asks for an equation to describe the situation. In this case, I want my equation to equal my total of 142. Put the wrong number there. And so the way that I'm achieving that 142 is I'm starting with 70, and I'm adding to that $12 for each shirt, and I've called X my number of shirts. So this would be my equation. 70 plus 12X equals 142. You could also have 12X plus 70. Now I'm ready to solve that equation. This is a two-stepper. And so my first step to solving this equation, remember I'm going to go reverse PEMDAS. So I'm going to minus 70. 12x will equal 72. Divide by 12. And so x would equal 6. That's my solution. And so then what this means about the context of the problem is that this means that it would cost $142, because that was my total cost, for 6 shirts. You might also say something like, it would take 6 shirts to have a total cost of $142, but you want to make sure that you're including both the 6 shirts and the total cost, because the total cost was our end result of the 6 shirts.